Algebra 2, Unit 6, Section 3, Classifying Degree and End Behavior of Polynomials. At the end of this lesson, you should be able to determine the degree of a polynomial and determine the end behavior of a polynomial function. So the first thing we're going to do is review some terms. So the first one we want to talk about here is leading coefficient. And the leading coefficient is the coefficient of the term with the highest degree. The degree of a polynomial is the highest exponential value or highest exponent value in the polynomial. And the terms are the separate pieces of the polynomial. So it's basically the monomials within the polynomial, which are separated by either plus signs or minus signs. So let's go ahead now and we're going to rewrite some polynomials in standard form and identify leading coefficient, degree, and terms. So standard form says we go from the greatest exponential value down to the least. So in this case, we have 6x squared plus 5x, and if there's no coefficient, it's 5x to the first, and then minus 7. So this makes it very easy to pull these following pieces of data out. So leading coefficient, 6. Degree, 2. That's the highest exponential value. And the number of terms. There are 3 terms. Our next one, x cubed minus 2x to the fifth plus 1 minus 9x. Well, the highest exponential value with its coefficient is 2x minus 2x to the fifth plus x cubed minus 9x plus 1. So leading a coefficient here is negative 2. The degree, 5. That's the highest exponent. Number of terms, 4. Our final one would be negative 9x cubed plus x squared minus 2. Leading coefficient, minus 9. Degree, 3. Number of terms, 3 again. So, how and why is it important to put the polynomial in standard form? Well, if we think about this, it makes it really easy to find lead coefficient and degree. It really doesn't matter with the terms because with terms, that is you can just count those. Okay? All right, let's move on. Okay, so let's talk first about our graphs that we're about to do here. So f of x equals x. The degree of this is first degree. And this is a linear function, so it's just going to be just like this here. And it's going to be a 45-degree angle. So we're just going to draw this in using our ruler. Quadratic functions, we talked about these in the prior semester. So this is a second degree polynomial, right, or a second degree graph, and that's going to look somewhat like this, right? Parabola. A cubic function is third degree, and it basically looks somewhat like this. Now, a quartic function, and these are rather interesting. It's fourth degree, very, very similar to the second degree polynomial. The difference is it's going to be a much flatter parabola. Okay, so there's going to be a flatness to this. And the same is going to be true for the quintic or fifth degree polynomial, in that there's going to be a flatness here, and then it gets high very quickly, and there's a flatness here, and it comes down like so. So my drawings are the best I can do. Not great, but you can follow along here and continue with yours. Okay, so if we have a odd degree polynomial versus an even degree polynomial, if the coefficient is positive, the graph of an odd degree polynomial is going to have this type of shape here. So what they're talking about with end behavior is that as x goes out to positive infinity, as we travel this way out to positive infinity, we're going to be this graph is going to be going up, and that's going to be going towards positive infinity. So as x approaches positive infinity, p of x is also going to be positively infinite. As we work to the left towards negative infinity, this graph is going down towards negative infinity. So as we work to negative infinity, this graph is going to be working to negative infinity as well. Now, even degree polynomials will behave like this. They're going to be here, and they're going to come down and go back up. They're going to be somewhat parabolic. So we would say if this is approaching, as we're approaching positive infinity out here, we're going to be going up to positive infinity here. So we're going to say the end behavior as we approach infinity is going to be a positive infinity. The difference here is as I approach negative infinity, I'm still going up over here, so that goes to positive infinity as well. So even degrees go in the same direction, odd degrees go in opposite. Now, if it's a negative leading coefficient, we can look at this and say, okay, what's going to happen? Well, this is going to be reversed. So this graph is going to be doing this type of behavior. So as we approach positive infinity, this graph is going to be going to negative infinity. And as we approach negative infinity, it's going to be approaching positive. With a even degree, we're going to be in this type of situation like this. Right? So negative coefficient, even degree. As we approach positive infinity, the graph is going down to negative infinity. And as I approach negative infinity, again, this is going to be approaching negative infinity. So the lead coefficient tells us whether it opens up or down. So now we can take a look at some further examples. Okay, so we can look at the lead coefficient here, and it's -1. So I'll write -1, and this makes it a negative coefficient. The degree of the polynomial is 4, which makes it even. So this is going to be both tails of this polynomial are going to be going in the same direction. Since the lead coefficient is negative, we're going down, and we're both going in the same direction. So in this case, it's going to be, both of these are going to be negative infinity. Okay. Our next one is 2x to the fifth plus 6x to the fourth minus x plus 4. This lead coefficient is 2, which is positive. The degree of the polynomial is 5, which is odd. So this means we're going to be going, one side's going to be going down, the other side's going to be going up. So our end behavior for this, though, is that it's going to be the same. If we're going to start from left to right, this is going to be going up from left to right. So as we go to positive infinity, we're going to be going to positive infinity here. And as we move to negative infinity, it's going to be negative infinity here. Okay, so what's the middle of the graph going to look like? Well, that will be coming up in further lessons.